So let's jump right into a couple of things that we noticed in terms of the Chapter 11 project. I sent you a message saying don't submit it yet because I want to make sure that we notice just some misconceptions on the 11.7 homework. We'll talk about that and then we'll talk about the project here quickly. What I want to do is show you guys really quick in Schoology. Um, Hopefully you can do this at some point today. So if you go to our Schoology page, homework answers, I put these up a little later than usual, so they weren't there right away after school. But if you click on 11, chapter 11 homework answers, and then we've got the Google Slides from 11.7. I want to quick talk through that just so you guys can see. It has my worked out solutions for each of the 4 slides, and we'll talk about a couple of them here just quick, so you guys get an idea of what the expectations were. Now, the trapezoid was a little bit challenging. When I would do the formatting, it says the width, which is always the largest width from left to right, that was 6.42 inches, and the height was how tall this is. And when they measure this in the formatting options, it's almost like they make a rectangle out of it, and that's how they get the width and the height. So then we did talk about sliding the trapezoid up to estimate the top base. And that top base I estimated at about 5 inches. So when I when I have these measurements here, I just redrew this shape so students looking back could see what I was thinking. Here's base 1, base 2, and then the height. And the area formula for the trapezoid is 1/2 base 1 plus base 2 times the height. So I calculated the area right here of this shape. So it was 16.2735 inches squared. Now, if you're the only difference you should really have in this problem is maybe you estimated base 1 to be different, but it shouldn't be that much different. So your answer should be somewhat close to mine for the area of this target. All right, so that's the first part. Well, actually, that's kind of the first 3 parts. What's the name, trapezoid, what are the dimensions, and then what's the area? Now, the geometric probability, that's the thing that I think we really want to focus on because I don't know if students 100% grabbed the concept of what is the geometric probability. Well, let's just think of this visually. If this slide that I'm showing you let's see if we can get the whole thing right here. If this whole slide, kind of not the white part, but the dark gray, if that was my target and I threw a dart here, what's the geometric probability of hitting the shaded region? Well, what is geometric probability? It's the area of what we want, which is the area of the trapezoid. So that's the work that I found right here in step 3. So it's that answer over the area of the entire shape, or the area of the entire slide. Well, that was a 10 by 5.5 inches, and that area was 55. So look at how I wrote this. Geometric probability is the area of the trapezoid over the area of the entire slide. So your probability should have been somewhere close to 0.29588. And then I wrote that as a decimal as well. Notice the fraction isn't reduce friendly, so I wrote it as a fraction just so you could compare. But the big things I'm looking at were the decimal and the percent. Okay. Now, we didn't ask you to write all 3, so if you wrote one of them, it was acceptable. But what I noticed is I was getting answers like 80% or 70%. Well, looking at this picture, this trapezoid does not take up 80% of the space on this page. So in that case, you had a calculation error. Maybe it was the area, maybe it was your total slide area. I'm not really sure, but we didn't want those errors to occur on the project. Homework, that's where you check your answers and test. If I look at problem number 2, this one was just a little bit different because it was a rhombus or a kite. I called it a rhombus in the direction, so that means we have to do our 1/2 diagonal 1 times diagonal 2. Well, the width is the full width, which is diagonal 1. The height is diagonal 2. And I just redrew my picture to kind of visually help those dimensions kind of appear differently. And then 1/2 diagonal 1 times diagonal 2. Here's my area, 13.125. And then the geometric probability is the area of that kite or rhombus over the total area. Now notice, my total area is 55 units or inches squared. That's the exact same thing you're going to use for your project because you're dealing with a 10 by 5.5 inch rectangle. So then what did I do for geometric probability? I took the area of what I want divided by the area total, and that gave me 0.23864 or about 23.864%. Okay? The one that I was kind of thinking students might struggle with was this one here. And this was the one where if you were to separate the two, you would have a parallelogram and then you have a triangle. And I calculated each one of those different. So parallelogram was 4 inches by 3 inches. And that area is 12. And then I calculated the area of the triangle, which was touching it. They're not overlapping, and that's important to think of. And that width was 3.1 and the height was 2.59 based off of the right click on that picture, and then that was the formatting options to find the size of that shape. And I just redrew this here. You can see the width and the height, and then I calculated that area. So now I have my total area for the geometric probability is the area of both of these shapes added together, so 12 plus 4.0145 over the total, which is 55. And notice, if you were getting answers that were in the 70 to 80%, this does not take up 70 to 80% of the entire space on the page. So visually, you should have a rough idea. If you made a mistake, you need to go back and look at that. So I hope you'll go back and just check these answers with your work from 11.7, just to make sure that you understand what's going on. So here's what we noticed. We noticed some errors with geometric probability. So let's talk about this really quick. You don't have to write these down as notes. And if you want, well, I will be posting these once we get done with our class today in class so we can talk about it. But let's say that I wanted to throw a dart and I wanted to hit the blue circle. Okay? I only wanted the blue, not the red, but I wanted the blue target on this. What is the probability of hitting a blue piece? Well, what do we need to do? I need to take the area. So what is probability? Probability is the size of the winning options. Well, when we say size, we're referring to area, right? And when we say winning options, your winning options are what you want, right? Your target. Well, in this case, I want the blue shape. So what I want is I want the area of the blue circle. However, now I didn't give any dimensions and we're not really going to calculate this, but we're just visualizing it. So I have the area of the blue circle, but then remember this red circle is actually being cut out of it. So I would have to subtract the area of that red circle, and that would give me just all this blue stuff. So that's the area of what I want over the total area, the size. And again, what is size? Size is area, and the size of all options, this is the area of the entire shape. Okay, so in this case, it would be the green circle. Now, that's for this specific problem. If we were doing this in terms of a board and we had a slide around it, then that would be the 55 because that's the size of the screen. But I'm just talking about if this whole shape, the largest the shape was the green circle. So notice I would find the area of the blue portion and then divide that by the area of the green. And that's what we want out of the total. And then that answer we can write as a fraction decimal, and or percent. Okay. Now we didn't tell you which way you should write that, so any one of them is fine. To be honest, our goal was to get the goal of the target or the project was to get close to 50%. So I would write all my answers in terms of percentages. Now, let's say, for example, that this answer, okay, let's say that this blue region occupied, I'm not positive, but let's say it was 47%. Oops, I wrote that wrong. It was 0.47 or 47%. Right? Let's say that that is the answer to this problem. Well, what is the expected value? That's where a lot of the questions kind of came about, and that's why we didn't want you to turn your project in yet. So we're going to talk a little bit about expected value. There's a description that you need to read on your project slide, but the expected value is the return of your investment. Okay, well, what is it? The expected value is where you take the probability of that event times the winning amount. So let's say that this green example was my game. And let's say that if you paid, I don't know, a certain amount. It doesn't matter how much you paid to play the game. But let's say you paid $2 to play this game. And you got $1 if you hit the green. You got $2 if you hit the blue, and then let's just say that if you hit the red, that was worth $5. Okay? So these are the expected values if you hit, and we want to figure out what's the probability of hitting the blue. So my expected value, if it costs me $2 to play the game, I'm going to take the probability of the event. In this case, our event was what's the probability of hitting blue? It's 0.47. And then times, what would I get if I hit the blue? I would get $2. Okay? And then we're going to multiply that together. I'm going to call this EV as for expected value. So it's the probability of your event. That's what you guys are calculating times whatever you decide the winning amount is. In this case, we decided it was $2. So I'm going to do 2 times 0.47, and that means that the person playing this game would expect to win 94% back by hitting the blue, 94 cents back. So let's think about that. You're a contestant. You come up and you pay $2 to play this game. And if you want to hit the $2 amount, then you would expect every time you throw a dart, you would expect to get about 94 cents back. Now, that's not exactly how it works, but that's the way the law of averages work. But there's different probabilities, right? Because it's not just the blue, it's the green and the red. And I sent a video link for you guys to watch if you were having questions on expected value. I think I did. If not, I'm going to put it in the chat, and it'll go over another example like this. Okay. Now you might still have some questions about it. There's one more example we're going to do with expected value in the next slide. Okay, but then the question is this a fair game? Okay. Well, if I removed the $1, if I removed the options here of winning $1 and $5, and the only way you could win this game was hitting the blue, and you paid $2, but you expected to get 94 cents back, that's not fair for the person playing the game. That would be kind of a carny game that they would be ripping you off, right? So what is a fair game? A fair game is where the expected value is equal to the cost of the game. So if I wanted to make my game fair, there's one or two things I could do. I could change the probability to make this closer to getting an expected value of $2, or instead of making it a $2 prize, what if I made it a $5 prize? Or what if I made it a $10 prize? Then you can change the expected value compared to the cost. So there's some things you can do within the game, either increase the amount of that the prizes are worth, or decrease the cost that it takes to play the game. Okay? So those are some things to think about with expected value. All right, let's look at this example. I don't want you to write it down. I just want you to look at it and see. So good question, Angela. She asked, in our project, do we want our game to be fair in the end? You don't have to adjust it, but you want to talk about it. Is it fair or is it not? So once you get it, obviously when you design your board, you're kind of seeing things come out, you're calculating your area. But if your goal is to get that to be as close to 50%, if you have a 50% chance of winning, then that kind of evens itself out there on like the probability side. Then you would just have to kind of think about, well, what is the prize value versus how much is somebody paying to play the game? And I wouldn't change your game board, but I might say, to make this game fair, I would charge this amount, or I would increase the prize value to this amount. So that way you're not changing your game, but you can just make suggestions on how to make it more fair. So I'm not sure if that directly answered your question or not, but we can talk more about it during our work time. All right, let's look at this really quick. So Aubrey owns a small business selling clothes. She knows that in the last week, 36 customers paid cash, 8 customers paid debit, and 11 customers used a credit card. So one of the things that's interesting is we want to just think about, well, how many total customers did she have last week? So we're just going to go ahead and add up all those items. And 36 plus 8 plus 11 means she had a total of 55 customers, right? So we know how many from that statement, we know how many of them were, how many total customers. And that says if next week she's expecting 800 customers, that's quite a jump, but if that happens, about how many would you expect to pay with a credit card? Round your answer to the nearest whole number. Well, this is another expected value problem. So my expected value would be the probability of somebody using a credit card times the total outcome or the number of customers. Right? I might actually put the word total in there. So this is just a this is another way to view expected value. Well, I need to figure out what is the probability of getting a credit card. Well, we need to use the data from last week. 11 customers used credit cards. 11 out of how many total? 55. So 11 out of 55, which by the way, if I do 11 divided by 55, that is 0.20 or 20%. So we have 0.20 or 20% of our customers are using credit cards. And then what if the customers now, instead of being at 55, what if they jumped up to 800? Well, then we're just going to multiply the probability of that event happening times the total. So 20% of 800, we would expect 600 customers to use credit cards for that next week. So there's just another example of how expected value can be used. It's just the probability of the event times the total outcome. All right. I'll show you this in 1 second. Let's switch the order. So one of the things that I also noticed, I just kind of glanced at a couple, and you have to be careful. Let's say that this is your board, okay? What do you know? You know that this is 5.5 inches by 10 inches. So when you're calculating your probability, let's say I want the probability of the triangle. Well, it's the what you want. So I'd have to figure out the area of this shape using the length and width. So I do the area of the triangle over the total area, which is 10 times 5.5, and it's going to be 55 for everyone. And then that will be the probability for this target. Okay? And then you would do the same thing for this one, this one, this one, and this one. Now, one of the things I want to mention quickly, you have to be very careful because if you're placing your targets and if one of them overlaps the other, then you're covering up the area of one of them, and that's not accurate. So you don't want your targets to overlap, and you also don't want any part of the target to be outside of the game board, because then that doesn't count either. So just make sure your targets are not overlapping and they are all on the page. Otherwise, you're using inaccurate information. All right, last thing, and then I'm done talking. If you would like, I'm going to send you a link right now in the chat. And if you would want to watch another video on expected value, some of you, I emailed this to you earlier. It's about 7 minutes. The first minute, I believe, gets into more theory. I'm not really concerned about like the first minute of that video. It's the rest of it that just talks a little bit more about expected value. So here's what we got for the rest of our time together. You can work on your project. It is due tonight, so we want you to submit it by tonight. And then I'll be on Zoom, so if you have any questions, jump on. But if you don't have questions and you're ready to go, then you can submit it now, and there's no other homework other than if you have missing work, get that caught up. All right, so the rest of the time is yours. I've taken attendance. You can stay on Zoom or you can leave, but I'll be here for the whole time to ask questions. Enjoy the weekend.